All right, well, let's begin. We've only got 18 out of 40 students in the classroom right now. I've never really understood the thing where after you take an exam or submit a report, then you skip the next class meeting. That's never made sense to me. But I'm glad you're here, those of you who are listening and who are maybe watching later, because we're going to be covering some really important material that just sort of chronically there's poor performance on the exam. And I guess it's probably because so many people skip class on this day. So it's good that you're here because this is important stuff and you're probably going to see it on the final exam. So I looked through the grade book and what I saw was that 33 out of 40 of you have submitted the project. I'm going to look forward to going through those. It'll probably take me all through next week to do that. My Thanksgiving usually is eating a lot on Thursday and grading a lot the rest of the week. So I think that trend is probably going to go strong this year as well. So some announcements. The only thing that you've got left in the course as far as items to submit are homework 14 and the final. So homework 14 is due on Wednesday the 2nd, so before class as per usual. And then the final exam, final exam, I just wanted to double check on the date there. Tuesday, December 8th, 10:15 to 12:15. Yes, that's correct. So that's a 2-hour window, and the exam will be similar in format and expectations to the previous tests, except for that it will be comprehensive and cumulative. And it would be kind of hard in this class to give a test that wasn't comprehensive, since all of the material kind of builds on itself. But what I will say is that there will be added emphasis on the content that you haven't yet been examined on. So your last midterm exam was class 29, and that was October 30th. And so the information since then, there's more likely to be more questions and more points on the newer material that you haven't yet been tested on, but there will still be a couple of questions going way back to check for retention as well. Okay, so those are the announcements. Now today we're going to continue talking about cost estimation. This is the information that's in chapter 15 of your textbook. And we're going to go over cost capacity, factor method, activity-based costing. And one last thing, I'll renew the suggestion that you really should watch that video from Monday's class. Remember the train wreck where I wasn't able to share my screen with you, and so we didn't actually have a live lecture that day? I emailed a link that you should watch to go through the information from Monday's class, and it's important stuff, so please do watch it. Any questions on these announcements before we start talking about cost capacity equations? All right, well, if there are no questions, then let's move forward. All right, so take a look at these interesting swimming pools. Have you ever maybe gone on a flight someplace and you're flying in an airplane, and sometimes you'll be flying into a city, maybe the industrial part of town, and you'll look down and you'll notice a bunch of swimming pools like this. Of course, they're not actually swimming pools. Anybody know what these are? Any guesses on what we're looking at here?
Is it a water treatment plant?
It is. It's and to be specific about it, it's a wastewater treatment plant. So you wouldn't want to swim in these. What you're looking at, these, as I'm gesturing with the mouse, are aeration basins, and then these are clarifiers. And so that's a part of taking wastewater that comes out of your house, which includes, you know, the stuff that you showered in, the stuff that you flushed down the toilet, what comes out of your dishwasher and washing machine. All that wastewater is mixed together, and they're trying to go through a treatment process to make sure that it's okay to put into the rivers and lakes that are downstream. And so this is a big one. This is a big wastewater treatment plant. And let's say that your company built this one, and so you know what the costs of everything were. You knew how much the laboratory cost to build. You know how much the sludge digesters were, the aeration basins, you know the cost of that, and each of the clarifiers, you knew how much it cost. And so you have some good cost data from this one. And now your company is trying to figure out what's going to be the expected cost for this wastewater treatment plant. So what you'll notice is that the one in the lower right-hand side, it's much smaller. And so the question is how can you adapt cost data from a large thing to a small thing? Or vice versa, like where there's a size difference. Is it just as simple as maybe counting the number of clarifiers, so 1, 2, 3, 4, 5, 6, 7, and so on, and then do you just make it proportional and linear? Well, sometimes, but there are some non-linearities as well that have to be considered. And that's what the cost capacity equation will allow you to do, is it allows you to take into account when there's a size variation effect on the cost. And so this equation says that if you know how much it costs to build a certain thing, that's the cost of thing 1, C1. And you know how big that thing was. So Q1 is just the size of it. And now what you're trying to do is you're trying to predict the cost of a second thing. And so C2 might be that smaller treatment plant. Then its expected cost is going to be related to the size ratio between it and the item that you do have the cost data for. And then here's where the magic happens, up here in the exponent. The correlating exponent allows us to take into account nonlinearities in cost with respect to size. So if the x value is less than 1, then what you're getting is called an economy of scale. That is, you can think of it as a bulk discount. If things get a little bit cheaper on a per unit basis, the more you buy and the more you build, then you're getting an economy of scale. So think, if Marshall University was going to buy 100 hard drives, they could probably get a better price than if I'm just going to buy 1 hard drive. So that's an economy of scale. Or if you're going to build a 10,000 square foot warehouse, your per square foot cost may be cheaper than if you're only going to build a 5,000 square foot warehouse. So that's a cost advantage for larger size. There are a handful of things where there's what's called a diseconomy of scale, and that is where you pay a penalty for something getting bigger. Now think about a skyscraper. As a skyscraper gets taller, each additional floor isn't making the skyscraper cheaper and cheaper. It's getting more expensive, but it's getting more expensive at a faster rate because all of the floors below it have to be further reinforced, and the construction methods are becoming more complex the higher you go in the sky because you're having to maybe use a more sophisticated crane, or there are different safety considerations. And so diseconomies of scale are those things where a larger size is actually more expensive. And then if x equals 1, that means that there is just a linear relationship between size and cost. Okay, so to get a test of how this all fits together, let's say that we know the price and the cost of a relatively small water treatment plant. It's this smaller treatment plant is producing 0.5 million gallons per day of water. And the correlating exponent overall for the treatment plant is 0.14. So that's below 1, which means it's a cost advantage for larger size. Now, it doesn't mean it's going to be cheaper for making the bigger thing. The bigger thing will still be more expensive. It's just that it's less than twice as much for twice the size. So what we're going to do is try and project what would the cost of a 2 million gallon per day plant be. And so let's identify the variables here. So C1, it's the cost that you know, 1.7 million. And if you've got scratch paper or your notes printed out, maybe write this down in the margin. C1 is 1.7 million. Q1, the size of that thing that you already have the data for, is 0.5. Q2 is 2. And then x is 0.14. So I think in pretty short order you can see what the calculations are going to be for that. Let me bring it up on the screen here. So Q 0.5, C1 1.7 million, and so on. So we substitute it into the equation here. What that means is that that 2 million gallon per day plant is going to cost 2.06 million. And so you're getting 4 times the size for just a little bit more money. You know, the smaller one was 1.7 million. So why would it actually be like that? It could be that a lot of the cost just has to do with mobilization. You know, getting people and equipment onto the job site. And then once they're there, having them do a little bit more is really no big deal. That was the case one time when I cut some trees down in my yard. I hired, before I knew how to run a chainsaw, I hired some professionals to come in and cut down a couple of trees in my yard. And their price was, I think, like $200 for one tree or $300 for 4 trees. I mean, once they were there and on the site, they were happy as a clam to just keep cutting. So I had them do it. So that was just one illustration of how we can use these cost capacity equations. Now here's some data from a wastewater treatment plant, the different types of things that go into water treatment, different equipment types, and the correlating exponent for each. So remember, less than 1 means you get an economy of scale. So if you build it bigger, it's only a little bit more expensive. 1 means that if you're doubling the size, you're doubling the cost. It means there's a linearity between size and cost. And then if it's greater than 1, that's those cases where you're getting a penalty because something about it is making it increasingly complicated or more expensive. So if you double the size, you're more than doubling the price. That's what happens when you have a correlating exponent of more than 1. So take into account the sludge drying beds. So when you have less leftover solids in wastewater treatment, you have to dry them out before you can landfill them or apply them onto crops. And the bigger they are, the more complicated it is because the center area is relatively inaccessible. All right, so we have this in-class exercise. I hope you've got it printed out and available to you there, and if not, you can just read it off the screen. Let's try this out. We have 3 different things that are going to go into this treatment plan, and we're combining this idea with one of the concepts from Monday. Cost index was one of those really important concepts from Monday's class, and so we're going to combine together the cost index and also this cost capacity equation. And so not only is the data that we have for a different size, you know, like the data that we have, it looks like it's for a smaller size. We have this aerated lagoon that we know cost, the original cost of the smaller one, C1, was 3.3 million, and the size of that aerated lagoon was 2 MGD. So not only is this new one we're going to build larger, but also the cost data that we have here was back in the olden days in 2010. So we know that things back then cost less than they do now. And so we're going to correct for both the inflation of prices between the 2 time periods and also the difference in size. And so what I'd like you to do is find out how much is this larger aerated lagoon going to cost, how much is the larger blower, how much is the pump, accounting for the index I, and also the difference in size Q. And then aerated lagoon, blower, and pump, if we want to, let me see if I can get the table so that it's up on the same screen at the same time. If you've got it printed, it's not an issue, but let me bring this up so that we've got the table. So we want the aerated lagoon, the blower, and the pump. All right, so aerated lagoon, lagoon aerated. So just write this down. It's 1.13. X equals 1.13 for the aerated lagoon. The blower, correlating exponent 0.46. And then the pump, $0.69. All right. I'm going to pause for a second, and you're going to crunch the numbers, and then you're going to let me know how much each one of these things cost on any one thing. Let me just bring up the solution and see if you had the right idea. If you were headed on track. Maybe you didn't get through all the calculations, but let's just see if you had the right idea. Okay, so like I said, the cost data we have is from the past, and so we need to scale up the costs because of an increase in size and also because of the effect of inflation. Just things are more expensive nowadays. And so the aerated lagoon, for instance, you can see that I've begun by just identifying all of the variables that we're going to apply here. So the size of the smaller one, the size of the one that we're trying to predict the cost of. So that's item 2 is the one we're trying to predict the cost of. We know the cost of the original one, the correlating exponent, and then you can see I've substituted in here the cost index data. And so we've got the old price in the denominator and the new price of the cost index in the numerator. And so, things are 19.7% more expensive in 2017 as they were in 2010. And so that factor, which is highlighted there in blue, accounts for the increase in cost due to the passage of time. And then the 3.13, this is the factor that accounts for the increased cost because of the difference in size. And so overall, this larger aerated lagoon constructed later on down the line when things are just naturally more expensive, it's going to be a $12.46 million aerated lagoon. Okay, so are there any questions about the general idea here? The blower and the pump are just going to be kind of repetition of the same thing, where we have substituted in the size of the known one, the size of the one we want to predict the cost of, the known original cost, the correlating exponent, and then this same factor accounting for the increase in prices due to the passage of time. So it means the blower is going to be $733,000. So for that one, we didn't have a diseconomy. So the 1.13 on the aerated lagoon, you kind of get that penalty for making it larger. The blower doesn't experience that penalty, though. We're getting kind of like a, it's only a little bit more expensive for being a lot bigger. We more than doubled the size, but the price is only 1.6 times larger. And then you see the same approach for the pump. So I think there's some questions on the homework like this. And I haven't written the final exam yet, but questions like this sure are nice on the final. So I'm glad you're here to work through this example today. Any questions before we move on? Okay, so remember, that is the cost estimating relationship using the cost capacity equation. The next approach that we're going to talk about to figuring out how much things cost is called the factor method. And the factor method uses the idea that you don't necessarily have to know the price of every single thing in a project, that sometimes you can get a rough idea of how much a project is going to cost by knowing just the cost of one component. And let me mention, I used to live over in Dubai, and one of the great things about living there is how good the food is. There's lots of really great restaurants, but it's a little bit tricky because there are some restaurants that are super expensive and some that are cheap, and the quality really isn't that much different between the two. And so you kind of got to check out the menu to kind of get an idea of, is this the kind of restaurant where it's just like inflated prices and you're going to end up kind of regretting you didn't go somewhere more cost effective. But what I would sometimes do is I just look at how much are they charging for a bottle of water. Because roughly speaking, if I knew how much they were charging for a bottle of water, then I could predict the overall cost of the meal just by multiplying it by 10. So there were some restaurants where I'd pay 3 dirhams for a water and I'd go out of there paying 30 dirhams, which is like about $8 for the meal. Whereas there were other restaurants where you're paying 20 dirhams for the water, and using that factor of 10 idea means you're going to walk away from the meal paying 200 dirhams, which is about $55. And I didn't like restaurants like that because there were plenty of places you could go and get fantastic food for just kind of a pittance. So this is the overall idea, is that if you know the cost of a piece of major equipment, then you can predict the overall cost with some sort of a multiplier, H. And so in my case, my water to meal multiplier was a factor of 10. Another way of accounting for the costs is by taking into account the indirect costs that have to be kind of put on top of direct costs. And this is reaching back a little bit, but I think you may remember that we talked about how the direct costs are those that are directly attributable to a certain level of activity. So, for example, if you're making Twinkies, then the direct costs are those that are associated with how many Twinkies you're making. So like the expense of the plastic, the hourly labor of the people who are there stuffing the Twinkies into the plastic. The cost of the electricity to operate the machines. All of those are direct costs, but then the indirect costs are the things that you just kind of always have to pay regardless of the level of productivity. And so in some ways they're kind of related to fixed costs, but the indirect costs are those that are hard to allocate to a certain output. So like accounting, management salary. Indirect costs might be the insurance that you have to pay. And so in this example, what we're going to do, this next part of the example, let me scroll down to it here. We have a generator where the major piece of equipment, we know the cost of the major equipment is $975,000. And that's the only thing that we know the actual price of, but our company has done this sort of thing before. And in this example, our company knows that normally the cost of pouring a concrete pad is about 39% of the generator cost. And so you don't necessarily have to go and get like a rebar estimate and a concrete estimate and like how much does it cost to finish it and all that. But just roughly speaking, the cost estimators know that it's about 39% of the generator to put the pad into place, and then to train the operators is 16% of the generator cost. And so if we look at the formula that's going to be applied here, let me paste that over all of this so that we've got access as you work on it. Oh, that's big. Sometimes PowerPoint doesn't play nice with other programs. Get this to be a good size. That's a little better. All right. Okay, so C sub E, the cost of a known piece of major equipment, $975,000, and then the direct cost factors that are known are for the concrete pad and the operator training. And so if you look at the formula here, we're saying 1 plus 1 representing the cost of the known equipment, and then all of the other direct cost factors. And so all of that's multiplied together, and then brackets means once you have found the result of that quantity, then you multiply it by 1 plus the indirect cost factor. And here our indirect cost factor of 27% is that 27% is the cost of like the accounting services and maybe management salary. And so all of those indirect costs have to be applied as well. So estimate how much is it going to cost to put this generator into service. And I'm actually going to wait until someone mentions it in the chat box. I'm not going to skip ahead like I sometimes do. I want to see if you can figure out what's the total cost, C sub T, of putting this generator into service. All right, Ethan's got it. Well done. Let's take a look. too much. All right. So you can see the calculations here that the direct costs are $1.5 million, and then the indirect costs are 27% additional. So in total, it's going to be $1,919,287.50. So that's the estimated cost of putting the generator into service. So now what would a company do if it was actually going to be bidding on something like this? Well, you may want to round up a little bit just to put some profit and safety factor into your estimate. But of course, if it's a competitive bidding scenario, then you don't want to overestimate too much, because then someone else may underbid you and you get the you lose the opportunity. So it's really a balancing act. All right, so are there any questions on this example? Well, let's keep it moving. All right. Indirect costs are difficult to assign to a specific output. So the types of things that you are going to be including in the indirect cost category would be like taxes that you have to pay. These are all expenses, but sometimes it's hard to tie it to a specific output for a company. Like if your company is generating hard drives, if you're in the hard drive production business, it's hard to say how much different divisions of the company should each bear in terms of the taxes. Your company may produce more than one thing, and that complicates even things further. Like if you have a company that is in manufacturing, but some of the things that you manufacture are very small and don't take up much floor space in the factory, and other things are large and take up a lot of floor space, then you have to start considering how do you recapture the indirect costs? Is it just on a per dollar basis for how much profit each one of them is generating, or do you go further and look at things like how much space is occupied for the different functions of each department of the company? Or if some of the things that your company is producing is really energy intensive, but other things that your company sells is less energy intensive, then you may need to try and capture a greater proportion of the energy costs by those goods that are using more energy during their production. So allocation is the idea of figuring out how to pass along the expenses that your company incurs. And so in the next part of this in-class exercise, in the here we are, indirect cost allocation. All right. We're considering the hypothetical case of you've got a construction company that does three different things. Your construction company has an excavation subsidiary, a steel assembly division, which is the people who will like put the reinforcing steel together before concrete is poured on top of it. And then your construction company has a group that does surveying. And so we know things like how many employees are in each division, how much revenue each division is generating, how many projects they have, and so on. But the parent company of these three groups, the holding company that actually owns them, has $6.9 million in indirect costs that have to be recovered. Meaning, this is the expense of maintaining a headquarters and filing income taxes and doing the accounting, and just these are all the expenses that the headquarters operation has to pass along to the actual revenue centers of the company. The headquarters isn't actually generating profits, but these divisions that headquarters own is generating revenue and profits. And so they're trying to figure out some different ways to figure out how much each of the three companies has to chip in, because it's not a rational basis to say, well, let's just divide it by 3. because you can see that these are widely varying companies, the three different divisions. The excavation company has tons of revenue. It's by far got the largest base revenue of the three, but the steel assembly affiliate has the most employees. And so there's different ways of looking at this, these indirect costs, and how to pass them along. So we're going to consider some of the different approaches to figure out how to allocate that indirect to the different divisions. So in step A, what I suggest is let's figure out the proportional indirect that should be passed along to each of the three divisions based on their revenue. So this is a weighted allocation. You probably remember weighted averages that we've done before. Similar idea here. What we're saying is that the excavation company, since it has the most revenue, it should pick up most of the indirect costs as well. And the proportion it's going to pick up will be its revenue compared to the total revenue. So add up all three together in the denominator, and then in the numerator you'd have just the excavation company's revenue. And let's find out in step A what are the indirect costs that are allocated to each on the basis of revenue. Then in step B we move on to just what if the excavation company is going to pass that fee along to their customers. How much should their surcharge be? And if you ever mail packages at UPS, and there's plenty of companies like airlines that also charge surcharges, but a few years back UPS started tacking on a fuel recovery surcharge, and then it stayed on there even when fuel prices came way back down again. Surcharges are just added fees that companies use to pass along specific expenses to their customers. So telephone companies are awfully fond of surcharges, and the cable company, and your stupid trash company, and the water company, and so on. They all love to pass along fees like as a separate charge on top of the base rates that they also charge you. So what we do here in B, C, and D is we're going to figure out where does that $6.9 million come from? How are you going to pass it along to the customers? So it's going to be on the basis of the assembled reinforcing steel and on the basis of the base revenue. So let me pause for a second and let you figure out how much each of these three divisions has to pay, and then the scheme that they're going to use to pass along the expenses to their customers. Okay, I brought the solution up on the screen. Okay, part A, we're trying to figure out, in part A, we're trying to figure out how much has to be recovered from each of these three divisions. And if we're doing it on the basis of their revenue, then the excavation company is going to pay the lion's share of the indirect. So it's going to be paying $5.3 million compared to just over $1 million for the steel assembly affiliate, and then the surveying division about $554,000. Now B, C, and D are all about passing those expenses on to the customers. And so if you're going to add some sort of a surcharge to excavation expenses, and the excavation company did 180,000 cubic meters of excavation last year, then what we have to do is divide the cost that they incur with the volume of business that they did last year, and we find that they're going to have to pass along to their customers $29.92 for every cubic meter that's excavated. And then for the steel assembly and the surveying division, you can see the other approaches that are done there. In part D, I think I maybe overcomplicated a little bit. You could probably get the same 39.6% just by dividing the revenue that they have with the expense that they're paying to the parent company, but 39.6% all the same. All right, so the last part of today's lecture has to do with activity-based costing. It's really closely related to what we were just talking about. And in activity-based costing, there's some important terms here that you need to have the definition for. A cost center are the things that a company sells, and they receive the indirect costs so that you can account for their true cost of operation in addition to the direct costs. And the activities are those support services that are provided in order to generate the final products of the company. And then the drivers are how much volume or how many, how much support is given by the departments that provide the support to each of the drivers. And so just to illustrate how this fits together and what it means, let's consider the case of if there was a college that had 3 different majors. If there was a college that had engineering students, safety technology students, and computer science students. And so you can see for each of those different departments how many faculty members there are, how many students they've got, the number of computers and support calls. Well, what if the IT department knew that it needed $145,000 to support that particular college, and now they're trying to figure out how much each of those 3 organizations should have to pay into that $145,000. So this is just an allocation method that looks at the different ways to come up with how much should be allocated from these each of these 3 departments. And one way to look at it maybe would be on the basis of how many support calls the IT department gets from each of the 3 divisions on a weekly basis, or maybe another argument could be made that the IT provides support to computers, and so it should be on the basis of the number of computers that they are servicing, or maybe the number of students, because each one of these things is going to add to the workload of the IT department. And so what the activity-based costing does is it looks at the different activities and services that IT is providing, and it comes up with an allocation method having to do with each of them. And so since we've just got 2 minutes left, let me jump straight ahead and show you what the calculations look like when you do something like this. If we were going to allocate the costs on the basis of the support calls, then what you'd find out is the total number of support calls in a week, which is 13, and then proportionally of the $145,000 that has to be collected to send to the IT department, each of the 3 divisions is going to have to pay according to the number of support calls relative to the total support calls per week. And so you can see in that case, because the safety technology group had 6 support calls per week out of the 13, then that means if we were using this approach, they'd have to chip in the most of the 3 departments because they had the majority of the support calls, or at least a plurality of it, not the majority. The most. In the case of if it was on the basis of the number of computers, then there's 100 computers in total, and 35% of those computers are engineering, 20% in safety, 45% in computer science, and so that's a very different allocation of who has to pay how much. And then students, it's the similar thing. And so in the end, what you'd maybe want to do is a blended approach that took each of these 3 methods into account, and maybe you took the average of the 3 different methods, and then that was the means of determining how much each organization had to pay. But the overall idea is that with activity-based costing, you look at some indicator of the expenses generated by each department, and then you allocate the indirect costs on the basis of those activities. 11:49, we're out of time. Let's just take one last look at the announcements before you begin your Thanksgiving break. Well-deserved break. Homework 14 is available now, and it's due on Wednesday the 2nd, and then our final exam Tuesday, December 8th. Hope you have a great vacation. Try and stay safe. I'll be grading your papers, and I'll post the grades for each student's work as soon as I do it, and so they may be popping up as early as today. I'm anxious to go through some of those and see how it went. So that's it. Hope you have a good one. I will see you a week from Tuesday. Bye-bye.